Well, good afternoon, and thank you very much for hanging in there. I appreciate your stamina at this point in the event. My name is Ray Williamson. I'm 23 years with Sika Corporation. I'm the Director of Product Engineering, and I have a background in a lot of different things. I feel I'm in the room full of experts today, and I kind of feel like a generalist. You know, I know a little bit about a lot of things. So today, we'll talk about some polyester polymer concrete bridge deck overlays. So part of the product offering that we have at Sika and Quick Bond, and just to explain real quick, you know, Sika Corporation, Sika Corporation has been on a tear these last few years. If you keep your eyes on the trade journals, we've been acquiring a lot of companies in recent years, and Quick Bond Polymers is a very recent acquisition from about 2 years ago. A lot of synergies between our company and theirs, so we thought it was a natural. And part of the product offering that Quick Bond brings to Sika includes high molecular weight methacrylates, and we'll see in a couple of moments that the primer component of the overlay system I'm about to present is a high molecular weight methacrylate type chemistry. Today's topic, polyester polymer concrete, will be our main focus, but we also offer hybrid composite synthetic concretes, known as HCSC, thin polymer overlay advanced overlays, thin polymer overlay advanced products, as well as high friction surface treatments. So polyester polymer concrete, or as we refer to it as PPC, is a non-cementitious polymer concrete installed like regular concrete would normally be. Its primary application is for bridge deck overlay work for the preservation and rehabilitation of the bridge to preserve the surface, extend the lifespan of that driving surface. We also have other applications where we'll do joint headers as well as full depth joint repairs, patches, full depth or partial depth. The product itself is very, very versatile. We'll do some closure pours, overlays on grid and orthotropic steel decks. This particular technology has over 40 years of proven history. And since that time, with Quick Bond Polymers, over 120 million square feet of bridge deck area nationwide has been installed. So a little bit of the history. The PPC development began in the 60s in the state of California, whereas California Department of Transportation and Oregon Departments of Transportation were leaders during these trial periods when the technology was first being investigated. The same resins and aggregates used back then really have not changed a whole lot since then, and that's based on their successful track record. I mean, Sika and Quick Bond Polymers has direct lineage from the 1970s to that original development of the technology. The components of the system will include a high molecular weight methacrylate primer, which can be adjusted based on the temperature conditions in the field, substrate temperature being the driver. You know, anything from down to 40 degrees up to 100 degrees is possible to install these types of systems. The polyester concrete itself is a combination of graded silica aggregates, a polyester resin binder, an abrasive top sand, which gives the surface texture and slip resistance. In this example, the combination of components and ingredients contains no cement, no Portland cement, and no water. On the left side, you kind of see the aggregate that is pretty fresh out of the mixing truck, but then after it's finished and applied in the field, it will have a glassine type finish, which ultimately receives the oven-dried silica sand broadcast, and we'll see that in a moment. Some of the properties of this type of product include formidable compressive strengths at 6,000 psi, 800 psi in tensile strength, 1,500 psi in flexural strength, 1,500 ksi in modulus of elasticity, 0 coulombs in permeability, and a similar coefficient of thermal expansion to Portland cement concrete itself. You'll see two types in a moment of finishes that we can apply to this type of overlay system. One of those being a mechanically tined system, which is a mechanically tined finish, I should say, which is applied as the material is fresh, is still in its uncured properties. The tining occurs minutes after it's laid onto the already primed deck. There are other options as well, depending upon what the spec calls for, including a saw-cut groove, once again for the sake of drainage purposes, for the sake of also providing some additional slip resistance. The saw cuts are typically done 24 to 48 hours after the material has had a chance to be in place and develop its cured strengths. So applications and advantages of PPC include bridge deck overlays, accelerated bridge construction closure pours, full depth patching, full depth joints, joint headers, and grade correction. Nice thing about these products is that they are fast. They can be adjusted, as I mentioned, based on the substrate temperature condition, with the ability to adjust the formulation in the field by playing around a little bit with the accelerator dose in the mix. So any thickness greater than 3/4 of an inch, the reason why we ask for a minimum thickness of 3/4 of an inch is based on the size of the stone that's part of the aggregate blend. But we have done jobs that on small local patches could be as deep as 12 inches plus. We've done overlays. A recent job I was on, an overlay was about 1.5 inches thick for over 500 linear feet of bridge deck overlay. And that was a recent job I was on in North Carolina. So the temperature ranges 40 to 100 degrees. On smaller patchwork, you can get a little bit colder. We can go a little bit warmer depending upon the need, and as well as the ability of the installers to adjust the cure rates and make sure that this material is still workable during its installation process. One of the nice things and advantages is the fast turnaround time. Whereas we can turn traffic around and maybe bring that lane back into active traffic patterns within 2 hours after the installation is done. Now, how do we know that that job is ready? Well, an exercise that we'll do as the project continues, we'll wait a few hours, we'll hit those surfaces in random spots, especially the most recently installed locations, with a rebound hammer. When we know that we're up around 3,000 PSI or so, which is what most DOT specs will call for, we know that we are ready to now blow off all the unadhered excess sand and reopen for traffic. The system offers 0 coulombs of permeability and has a 35+ year proven service record. During installations, we confirm the deck temperatures with our laser thermometer by just shooting the deck temperature, making sure that we're at least above 40. Now, quite frankly, as I mentioned a moment ago, we could go a little bit colder, but most of the DOT specs will require us to wait until that deck is at least 40. So you know what? Now you're thinking about when are these jobs done? Early mornings during the typical construction day? Not always the case. You know, sometimes in the summertime, we're doing a lot of night work. I can tell you I've spent a few sleepless nights this past summer down in the state of North Carolina on a few projects in Pennsylvania as well, where we were doing jobs at night when the temperatures were, of course, cooler, but the surface temperature was still a little bit on the warmer side. And what we want to do is we want to be able to know what that temperature is on the substrate so that we know how to dose the installation and the resins with an accelerator, if necessary, in order to make sure that we are able to reopen in a timely manner. When the primer is applied, as you see in this photo, the primer is mixed very low viscosity, high molecular weight methacrylate primer. It's mixed with a catalyst and then basically poured out, spread very generously across the prep surface. And what I ask for in terms of a prep is we want a sandblast or a metal shot blast type of prep. If you're familiar with the concrete surface profile number convention, a CSP of 3 is very typical. Now, it can be rougher, and of course, the rougher that surface, the more material gets consumed in an overlay installation. But you don't want it too smooth, because not only are we looking for a chemical bond, but we're also looking for mechanical interlock. We're looking for an open textured, very porous concrete that allows that primer to kind of sink in and absorb and create a beautiful bonding bridge for the compatible overlay that follows. The installers, as you see here, they're spreading with squeegees. They've already poured the material. This is the primer that is being poured out from buckets after mixing. Could be spread with squeegees, could be spread with brooms. And we also ask the installers to kind of mop out and make sure that the primer does not build up or puddle in certain areas where that could be a little bit of a weak spot. You always like to try to remove the thicker primer. Thin is better in a case like that. The typical coverage rate, about 100 square feet per gallon, and if necessary for orthotropic steel decks, we can add zinc to the high molecular weight methacrylate primer, which will act as a sacrificial anode and prevent and control and mitigate corrosion. When the primer's down and we're ready to catalyze and mix the PPC, a volumetric mixing truck designed for this type of work is used. The truck is assembled with a hopper for the aggregates. It's a blend of fine and coarse aggregates, typically oven dried, to make sure there's no moisture incorporated into the blend. Then a 500-gallon tote for the polyester resin puts all of those ingredients together with the initiator, the MEKP, methyl ethyl ketone polymer, and the Z-Cure, which is our accelerator, if necessary. It's not always necessary to accelerate. Sometimes our substrate bridge decks are warm enough to move forward without the need for the accelerator. The truck itself is calibrated for the PPC spec, and most specs, DOTs that are very fond of this type of technology are calling for a typical 12% resin content in that overall blend of resin, aggregates, etc. The continuous auger mixes the PPC so that that truck, as you know, when the foreman gives the signal, the arm comes out, pours a volume of the material, and it's a continuous process moving over the primer, which is still in a tacky or slightly greasy condition to the touch. The computer printout at the end of the lane will give the inspector, the resident engineer, whoever is overseeing the project, will give them a printout of what those resin content percentages actually were. As the slip form paver, which is, I think, the best way to apply these products, although there are other ways to do it with vibradori screeds. There's also on smaller areas like shoulders, for example, a way to hand apply this product as well. And you'll see in an upcoming slide, we'll do it with hand application techniques for the headers for joints. But the slip form paver is the most efficient way to go. It compacts the material after it's placed. You've got a couple of guys on their hands and knees on the edges, finishing with hand trowels just to make sure we have a consistency from the beginning of that maybe 18-foot, from I should say the center of maybe that 18-foot long slip form paver, you know, to the edges of the placement itself. It sets the material to grade at a consistent thickness, vibrates it at the same time, and then controls the surface smoothness. As mentioned, your hand finishing on the edges and touch-ups, you know, sometimes you talk about hiccups, you'll see every now and then as that slip form paver moves across, you'll see a little spot where maybe there might have been a deeper part of the substrate where the material didn't fill in. You'll take your typical float and just push that material into place so that it's a nice consistent finish. While that material is still in an uncured, tacky condition, an oven-dried silica top sand is hand broadcasted onto the surface, not necessarily to refusal, but a generous amount, maybe about 1 pound per every 100 square, for every 10 square feet, excuse me. And then, you know, what we're looking for is a surface that absorbs the oven-dried aggregate, keeps it on top, but encapsulated. If you think about kind of an iceberg, you want the tops of that aggregate to be exposed to the traffic and ultimately be your wear course, while the bottom portion, 2/3 or so at the microscopic level, are being embedded into the resin. Texturing, as mentioned, is done with either tining or later with saw cut grooving. Here's an example of some joint headers that are being filled with the PPC. In the case on the left, you've got a relatively complex, or I should say a highly reinforced joint header system, and of course the joints are where the punishment occurs. As the traffic is moving across those joints and it hits whatever the expansion mechanism that allows for the movement, it's the joint headers that tend to be the weak spot due to the impact of 55, 65, 75 mile an hour traffic. There's always a movement capability built into those joints, of course, for expansion and contraction purposes, typically a foam type of expansion joint. And of course, I mentioned acquisitions earlier before. Sika had acquired a couple of companies that actually do the joint materials themselves as well in recent years. A couple of case studies. Richmond-San Rafael Bridge in 2007. I mean, these are the larger, more high-profile projects that we've done, although many bridges here in the Northeast specifically, I happen to be a New York resident, state of New York, New Jersey, Pennsylvania. Connecticut is beginning to now adopt some of the PPC specifications into their standard specs as well. But this particular project in Richmond, San Rafael, in California in 2007, very large, long span, a lot of material. Another high-profile project in San Francisco, the San Francisco-Oakland Bay Bridge, 2006 to 2010 was that installation. In New York City, the Kosciuszko bridges in recent times, going on about, doing my math real quick here, about 8 years old or so, 8 years going on, with a very successful performance thus far in the New York harsh environment. The B.E. Wright Memorial Bridge in 2017, this is a bridge down in North Carolina, also received this. I spent probably about 4 or 5 of my jobs this summer in the state of North Carolina, where this is now becoming a more and more popular, specified, and desired method of overlaying surfaces. 4 Grand Island bridges, upstate New York. The Goethals Bridge, which connects New Jersey to Staten Island. And a big, kind of a page turner for Sika and Quick Bond Polymers was the state of Pennsylvania adopting this into their specs and putting out a lot of opportunities for us to overlay over 400 bridges, 950,000 square feet total of PPC overlay. The Gilman Street Bridge over I-80, this is an interesting bridge out in California, whereas the busyness of this bridge, the kind of traffic it sees every day, 550,000 vehicles is your average daily traffic rate. The National Bridge Inventory deck rating on this bridge, since it was installed, still maintains a rating of 7. You may be familiar with the MBI deck rating system. There is a way of getting a higher rating, but apparently that is never given to the bridges themselves. It goes from 3 to 4, fair to good, 4 to 5, good to very good. We're in that very good, but, no bridges, from what I understand, ever receive a rating greater than 7. But the wearing course itself, since 1991, is 100% intact, which is, I think, an impressive testimonial to the technology. I appreciate your attention. I want to say thank you to Celeste, to the NEX workshop, for this opportunity to speak to you today. And if you had